How do you optimize embedded C4 memory constraints? Imagine trying to fit a full library into a tiny showbox. That's what optimizing embedded C4 microcontrollers is like. Microcontrollers have limited RAM and read-only memory, so you need smart strategies. First, understand your microcontroller's memory map by reading its datasheet. Know where the program code, variables, stack, and heap are stored. This helps you target your optimizations better. Use the smallest data types possible. Instead of using int or long, opt for unsigned 8-bit integer or signed 8-bit integer when your data fits. Avoid floating point calculations if you can do integer math instead, because floating point takes more space and processing power. Keep global and static variables to a minimum. These stay in RAM for the entire program run, so reducing their size frees up memory. Use local variables inside functions instead, as they are stored on the stack and are released after the function ends. Limit the depth of your function calls and avoid recursion. Each call consumes stack space, so keeping calls shallow saves memory. When passing data structures, pass pointers instead of entire structures by value. This reduces stack usage. Prefer static memory allocation over dynamic memory allocation with functions like malloc and free. Dynamic allocation can cause fragmentation and unpredictable memory use, which is risky in embedded systems. If you must use dynamic memory, manage it carefully and monitor heap usage. Store constant data such as strings and lookup tables in flash memory, not RAM. Many compilers support directives like progmem to place constants in read-only memory. This saves valuable RAM for variables and the stack. Use unions to allow different variables to share the same memory space when they are not used at the same time. Bitfields pack small variables into fewer bytes, saving space. Inline small functions where possible to reduce function call overhead and stack usage. But be cautious. Too much inlining can increase code size. Simplify mathematical expressions and replace complex switch case statements with if-else chains if it reduces code size. Use tools like map files and debuggers to analyze how memory is used during runtime. Profiling helps you find memory hotspots and optimize accordingly. Manage buffers and interrupts carefully. Keep buffer sizes just enough for the worst-case scenario to avoid wasting memory. Circular buffers are useful but must be managed to prevent overflow. Applying these techniques can make your embedded C programs run smoothly on microcontrollers with tight memory limits. Whether you're working on Internet of Things devices, automotive controllers, or consumer electronics, these methods help you develop reliable, efficient firmware. Remember, small changes in how you handle memory can lead to big improvements in system performance and stability.